So we're in number 20. So 20 says find the percent of the total area, which is 1, or 100%, under a normal curve between the given values of z. So 20 is between z equals negative 1.74 and negative 1.14. So when you give them two z-scores, where one of them is not the mean, but is something else, then you want to draw vertical lines associated with these z-scores. So we can take negative 1.74, which is about right here, and we draw that straight up. And then we take negative 1.14, which is about that. And we're looking for the area between them. So this is this area right there. And the question is what percentage of the total area. So if we can find this area, then we just need to multiply by 100. Again, we're not given any information about x bar or s. We're just given the z-scores. So how do we do this one? Well, again, what we know how to do is find the area between, the table gives us the area between the mean and some z-score. Now, because of symmetry, this here, if I take that, oops, and let me just group that together. So let me put that as a group, and then what I'll do is I will clone it, and then I will flip it from left to right. So let me move this back up. So all I've done is taken this area and I've moved it over here. And because of symmetry, they should end up being in relatively the same locations. So to find this area, I can find that area. Well, to find this area, what I can do is I can find the area from here all the way to the far end, like this. So I can go from the mean to here, and then I can subtract off the area from the mean to the left-hand side. So the red area is the blue area minus the green area, and that area is equal to that area. Now, if these were both positive, it would be the same. So if I said, if I asked it between z equals 1.14 and z equals 1.74, I get the same number, same area. Okay. So the blue area is from the mean to z equals 1.74. And the green area is from the mean to z equals 1.14. And the red is from z equals 1.14 to z equals 1.74, which is this area, which is the same one if you take the absolute value. So all we have to do now is we're going to find the green area, or the blue area. So the blue area is a function of the z-score, 1.74. So that's this area from the mean to the right-hand part. So I go to my table and I look under z-score of 1.74, which is in the 1, 2, 3, 4th set of data points. If you go to the top, you see you got z and a. So you come down the z column to 1.74, and I get 0.459. So 0.459. What that means is that 45.9% of the data is between the mean and this outer thing. Then I do the green. So the green area, which again starts at the mean, is a function of the other z-score. So I go down, I look on the third set of columns, and I start over there at 1.12, and I need to go to 1.14, and I get 0.373 area. So I get 0.373 area. And I just said that the red area equals the blue area minus the green area. So I have the blue and the green areas. So the blue area was 0.459. The green area was negative, well, let's subtract 0.373. And you just do the math in your calculator. 0.459 minus 0.373, and I get that the red area is 0.086. And what they asked, the question they asked was find the percent. So the corresponding percent is 8 point, you multiply by 100, you get 8.6. 8.6, therefore, 8.6% of the data lies between z equals negative 1.14 and z equals negative 1.74. So I finally remembered that I was really looking over here, but I found it over there, but again, because of symmetry. Okay, so that's good. Let me go ahead and clone this thing again. Okay, the next one is 25. So it says, 25 says, find the value of z such that each condition is met. So, so you actually have to go the opposite way. You have to use the area to calculate the z. Up to this point, we've used the z to calculate the area. So let's just draw something here, just approximation. We really don't know exactly where it's going to be, but we can at least get an idea. So it says in 25, 9% of the total area is to the left of z. Okay, let's say z equals 0. 50% of the data is to the left of z. One standard deviation is 34 or something. So if you take 50 and the 34, that's going to be 84. So 84% is on this side and 16% on this side. So 16 is going to be, if I drew here, it'd be about 16. So 9% is going to be somewhere in between these two. So I'm going to assume that my corresponding z-score is somewhere about there. And what I'm looking for is that 9% of this total area underneath the curve is to the left of z equals to negative 1 point. Well, that's the answer because I can see it, but 9% of the area. This area is 9% of the total area. So I know it's to the left here because left of the vertical line to be a small percentage has to be way over here. Okay, so what we're going to do is we're going to remember you're going to take the area and then you'll find the corresponding z-score. So in this case, the area is 0.09. Okay, 9% becomes 0.09 in area. Then you go to your table, and instead of looking in the z column, you look in the a column. So if we start in the first set of z and a, and you take your finger down and you just follow the A till you get to 0.09, and you can see it's about 0.23 for Z. But is that the right thing to be using? No, it's not. So we kind of have to work our way backward here again. Because of symmetry, the negative Z-score, you could have a corresponding positive Z-score here. So if I put this in the same location, so this height is the same as that height, the percent that are over here are going to be the same percent that are over here. Okay, so now I'm made it into a positive problem instead of a negative Z problem. But if you remember these kinds of problems, we can't just use this area here because that's not the way the tables are defined. So again, what we're going to have to do is we know that, let's say, the green area here, which is everything to the right of the mean, so the whole area here, the area, we'll say Z equals 0 plus. So that means everything to the right here is equal to 0.5. Half of the area is under this half of the curve. Now, we also can find the blue, let's use red, the red area here. This is the table. The table is set up for this area between here and some Z-score. So we can say the red area on the right-hand side here, the red area is going to be equal to the green area, which is where Z is positive, minus the am I doing this right? No, that's not right. So the blue area is going to be the green area minus the red area. And that's some Z-score, which we don't know what it is. Okay. So blue is green minus red. So we can solve for red. Red is equal to green. That's not green, that's red. So we're going to move this to the other side, makes that positive. So we'll have Z, area Z equals 0 plus, which is 0.5, and we're going to subtract the blue area, which is 9%. Okay. So what we get here is the green area is 0.5. We subtract the blue area, which is 0.09. So the red area is equal to 0.41. So this is, if this is 9% and the whole thing's 50%, then this has to be 41%. So then what we can do is we can use this area, and then we'll go find out what the Z-score is associated with that. So we go to the table, and you have to go to the third set of numbers, columns. And if you go down, so you're looking, you've got two fingers. Your left finger that you've got is on the Z column, and your right finger is on the A column. And you take it down until you see 0.41 in the area column. And that corresponds to a Z of 1.34. So from the table, the area, the Z-score that corresponds to 0.41 is Z equal 1.34. So that's this number right here. I kind of drew it. But because of symmetry, the answer is going to be Z equals negative 1.34. And that's your answer. I think they're looking for it in terms of Z. And that's the right answer, negative 1.34. So let's kind of review what we did here because it got a little confusing. it says, what is the z-score such that 9% of the data is to the left of that? That's this little red area. Well, what I said is because of symmetry, I can move this over here to the other side to make it all positive z. So then there's this blue area, which is the same as the red area over here. The table is based on the area from here to the z-score that gives you the area from here to here, but the area that I'm given is from this point to the right. So to get the red area corresponding to this blue area, I take the total area underneath the right-hand side, which is 0.5. I subtract the blue area, which is given in the problem as 0.09. So therefore, the red area is 0.41. And then I use the tables in the opposite direction to find out the z-score such that this area in the red marked is 0.41. The z-score is 1.34, but because of symmetry, it corresponds to negative 1.34 when I'm talking about this area. Okay. Okay, what's next? 29, and then we'll do a new recording. So now we're actually using some data, and it says the better light bulb has an average life of 600 hours. So which one is this? 20, 29. So this is true. This data applies to 27 through 32. So for all of those problems, the average lifespan, which is the mean, is 600 hours with a standard deviation of 50 hours. So again, I could put 60 here with a 600 here with a 50 standard deviation. So this would be 650 hours, this would be 700 hours, this would be 750 hours, this would be 550, this would be 500, this would be 450. So these are the actual data values. These are the z-scores. Then it says between 675 hours and 740 hours. So we could actually draw the lines there. We could convert them to z-score, but we don't have to. I'll show you how to do both. Between 675, so here's 650, 675 is right there, and 740 hours, which is going to be right there. It's real short. So what I'm looking for is the area associated with this. And this doesn't go all the way to the end. It stops right there. So how do we do this? Well, again, you got to use subtraction. In the previous ones, we went all the way out to the end because we were saying, greater than this, but here we've got, it doesn't go quite out to the end. So what we're going to do is we're going to find the area from the mean all the way to the larger z-score, which was way out here, just to there, right about there. And then we're going to subtract this area, which goes to the left-hand vertical line. So what I can say again is that the red area is equal to the blue area minus the green area. Okay. So how do I find? I can't calculate this directly, but I can calculate the blue. The blue area is associated with the z-score of the blue area goes all the way out to here, so that's a z-score out to, well, we haven't actually done the z-scores yet, so let's do this. So the z-score associated with the lower number, which was 675, is you take 675, subtract the mean, divided by the standard deviation, which gives you 75 over 50, which is 1.5, positive 1.5. And that makes sense because we're over here to the right of the mean. Then we have the z-score associated with the next number, which was 740. So you take 740 minus 600, divide by 50. So we get 140. 740 minus 600 is 140, divided by 50, which is 2.8. So the z-score here is 2.8. So now I can write those in. So the area for the blue area is for a z equal to 2.8, and the green is associated with the z equal to 1.5. Again, I have the table which bases the area going from the mean to some z-score. But this is between two z-scores, so I have to do from here to there and subtract from there to there to get the in-between. So the area that I'm trying to calculate, which can also be related to percentage, is the blue area. So I go to my table and I look under a z-score of 2.8. That's in the last column right at the top, z 2.8, a 0.497. So I get 0.497 from the table. And then I'm going to do the green. And the green is a z-score of 1.5. So I go to the third set of columns and I go down until I find 1.5 for z. Corresponding area is 0.433. 0.433, and therefore the net area that's red is 0.497 minus 0.433, which is 0.064, or 6.4%. 6.4% of 10,000. So they're asking how many light bulbs. They're not asking for just the percent. So now that we have the percent, change that to a decimal and then multiply that by the number. And if it was all of them, we'd have 1. So this is 6.4% divided by 100 to get the decimal equivalent. So you have 0.064 times 10,000. And I get 640. So if this area under the entire curve represents 10,000, this little red area represents 640 out of 10,000. Okay, so we're going to stop there and then we'll start a new video for the next group.